there, folks. Root Beer here, looking at our last question from Part A of our 2017 intermediate paper. So this is A6. In the diagram, 6 squares form a 2 by 3 grid. The middle square in the top row is marked with an R. There it is. Each of the 5 remaining squares is going to get an R, S, or a T. In how many ways can the grid be completed so that at least one pair of squares side by side is in the same row or same column that contain the same letter? So if I put an R here, it wouldn't matter how we fill in the rest of it. Or if I put an S and an S here, it wouldn't matter how we fill in the rest of it. Okay? Now, there's going to be a lot of possibilities, and maybe we have an R here and 2 S's here, and so there'd be a lot of case-based work, and it's not like we're going to say, okay, suppose there's exactly one pair side by side with the same letter, and then say, okay, where could that be? Well, it could be here, or maybe it's 2 T's down here. There's a lot going on. I don't see a clear way to organize it. I'm sure we could do it with cases, but it looks like there'd be a lot of cases, and there'd be a lot of cases just to get to have one pair side by side, and then this would have to be an S, and this one here would have to be, well, it couldn't be an R, it could be a T or an S, but this can't be a T, it can't be an S, so it could be an R, and that's just one possibility. We'd have to work our way through it. So there's a lot going on there. Okay, so we might try and find a different way. Maybe not case-based ways of counting everything up. Instead, what we can do, and this is a nice counting trick, is we can count the opposite and subtract that from the total. So here's what I mean. We know for a fact the R's got to be in the top middle. Okay? But then we've got 3 choices for the letter to go here, 3 to go here, 3 to go here, 3 to go here. 3 to the 5 different possible ways to fill in this grid, ignoring their conditions about pairs with the same letter or anything like that. There's 243 ways in total to fill in this grid. Okay? What we're going to do is we're going to figure out the ways to fill in this grid that don't obey the rule that they want. Okay? So, for example, we've got an R here that's given, so I won't put an R here, and I won't put an R here, and I won't put an R here. And we will specifically avoid those. And that might be something that's a little easier to count. And whatever that is, suppose there's 43 of those, we're going to subtract it from the total. So the total minus what we don't want will give us what we do want. And so this is often a nice way to calculate things when there are just too many cases, or it's very hard to get your head around things, or there's going to be a lot of double counting. Try doing the opposite problem. Okay. So what can we have here? So the R's got to go here. And now we can't put R's here, and we can't put an R here. Let's focus on the. So there's 2 choices for what we can put here. It could be an S or a T. Let's pretend it's an S for a moment. Okay. Now you could put an R here or a T here, but of course that T depends on whether or not there's a T here. And we can't have an R here, but we could have an S or a T here. And we could have an S here, but only if that's a T. Okay. I'm going to put a little RST here. I'm going to put a little RST here, RST here, RST here. Okay. Let's try and be sort of orderly about this. Let's look at this square. I know it can't be an R, just like the other ones. Okay. So we can only have an R, an S and a T here, an S and T here. And I can only have an S and a T here. So there's 2 choices for what this is. But what this does is it changes what these can be. Okay. So, if I put an S here, suddenly I can't put S's here. So I have a choice of RT, but I can't put T here. I can't put T in both of them. So that sort of limits our possibilities. Okay. But doing it this way sort of separates it into, now I've got to work out sort of what's going here and what's going in these columns. So over here, if I've got an S here, and I can easily swap it out for a T. I've got two choices for what goes here. We can't have an S here. We could have an RT or an ST, but we can't have both of them be T. So I suppose we could have no T's. So that would force it to be an R and an S. Or we can have one T up top, and that means, because we can't have an S here and therefore can't have a T here, that would have to be RT. Or we could have the T in the bottom, and so we'd have to have the S on top. So there's three choices, not for any of the individual squares, but for this column as a whole. Knowing that I've got RS here, there's three choices. And if I had put a T here instead, just swap everything, swap the S's and the T's. And it should be the same story here. We should get three choices. So once again, just to keep it the same idea, if I put an S here, I can't have an S here. So I can have an R there and an S above. That's not going to violate anything. I could have an R on the bottom, or I could have a T, but I can't have T and T. So if I put a T on the bottom, I'll have to have an S on top. So again, three choices for this whole column. So three choices for one column, three choices for the other, two for this middle square that I pick first, I guess. And that gives me 18 possibilities. If I wanted to, I suppose we could list them all out, but it's much better to sort of reason our way. So there's 18 that we don't want. So now if I subtract that from our 243 that we do want, 23, 233 minus 8, so it should be 225. 225 that have the condition that we specifically tried to avoid. Okay? Because 243 is all of them. 18 is specifically the ones that don't have this sort of side property. So these 225 represent everything else that's left over. Okay. There we go. That finishes off A part for our paper. Up next, we're going to be looking at B1 as we start the part B. The questions are worth a little bit more, and they do require written solutions. There's 3 of those, so feel free to give them a try, but I'll see you for B1 in the next video.